where there's some right here in the hall, clerk.
No, Molly, not in there. I have
Hello, and it's back. The truth is, this is the Cobra-matic, twin Cobra-matic, as you can tell. And it's back on my bench because I was so dissatisfied with the video, the last video I did on this, that I'm going to do it all over again. And try to be a little more, try to provide a little bit more useful information than I did last time. And try to provide some consistent sound as well. So that's what we'll do. And I'll start by explaining what the drive motor needed to play both 33 and 78s. So we'll start there. And then we'll move on to the undercarriage of this thing. I touched briefly last time on synchronizing the turntable. And I'll go through that again, but I'll explain what we're synchronizing and what the various elements under this deck do. And then we'll call that a day for this until I might be able to actually simulate. I said last time, I don't know, you may not have watched it, but under here is a solenoid that activates the record changer, pushes the record out, lifts the tone arm, moves it around, stuff like that. And the solenoid, in addition to the motor on the turntable itself, is powered by power from the tuner. This plugs into the 9H21 tuner chassis. So it gets 110 volts from the chassis for the drive motor, and it gets the, what is it? I think 6.3 volts for the solenoid from the chassis. But I might be able to figure out a way to make that happen without having the chassis hooked up. In any case, I want to do a better job than I did last time. And if last time was sufficient for you, don't watch this one, because it's going to be a better version, I hope, of the same information. Okay, we'll start with the motor and what had to be done there. So I'll lift the platter off and off over the spindle, and we'll get a closer look at what's down in here. Okay, the motor sits under the chassis, of course, but its drive shaft is right there. This is the primary drive shaft, and there's a spring wrapped around that to give the shaft the correct diameter to play against this 2-inch idler wheel and rub on the platter to spin it at 78 RPM. So when this switch is set to 78 RPM, the engine is directly driving the idler wheel and directly turning the platter at 78 RPM. When you switch to 33 1/3, back this way, you'll notice this brass part right here. This guy is what gets moved into place. And it pushes the idler wheel away from the main drive a little bit. And right there is a rubber belt. And the rubber belt that was on there was stiff and wasn't working very well. So I managed to get one ordered from our friends that whom you can see on the screen right now. And they provided both the idler wheel and this belt, as well as the grommets that cushion the motor from vibration, or cushion the rest of it from the motor's vibration, whichever way you want to look at it. So That's what had to be replaced. The idler wheel had to be replaced. The rubber belt that drives the 33 1/3 RPM capstan had to be replaced. And the rubber grommets that hold the motor in place had to be replaced. The motor itself, of course, had to be lubed, cleaned and lubed, which it was. If it were easy, I would pull the spindle, and I might still, and measure the RPM that the turntable does in both those speeds. I know right now I've gotten a good enough reading by putting my phone with its app off to the side that a 78 is fast. It's running at 79. And I suspect the same is true for the 33 1/3. But if I can figure out how to pull the spindle and measure the RPMs for you, I will do that. What next should we talk about? So that's everything having to do with the drive motor. Now this is working correctly. The next thing to address is over there. And over here, you can barely see it right there, but this floppy bit of metal is the lift pin that lifts the tone arm in preparation for swinging over and dropping down on a new record. And the new record can be either a 10-inch or 12-inch. If it's 10-inch, this thing is out like it is in, like it is now. If it's 12-inch, when it falls down, it trips this red flag back, and the tone arm then knows to only go in that far instead of that far. So that's what the red flag is for. It sets the width of the record. Now this lift pin for the tone arm was missing when I got this. I didn't realize it when I picked it up, but it was. So I had to make one. I will now take the tone arm off and show you what I made and explain a little bit about why it had to be done, and show you what I'm going to do as I think a better solution than the one I came up with. But we'll do that next. We'll take the tone arm off. The tone arm is held in place by 2 set screws, one there and one there. And the tone arm itself moves on a big swing mechanism down here, and we'll look at that later, right there. But to get the tone arm, lift the tone arm free without, if you want to replace the wire in the tone arm, you can do that just by lifting it free here. If you need to work on the mechanism, you're going to have to take the plastic housing off, but for this exercise we do not. So these 2 set screws I will remove, or loosen rather, and we'll lift the tone arm off. And we'll set that aside. Oh, I need to remove the needle from the cartridge too, so it doesn't get damaged. Let me do that. There. Set that aside. Okay, here's the lift pin, and this is what I made. It's 2 aluminum spacers that are threaded, screwed together in the middle with a length of brass screw, and then use some thread setter, some Permatex thread locker blue to make it a semi-permanent bend or bond. You could take it apart if you wanted to, but it's strong enough for our purposes here. Then on the end of that is another brass screw. I bought these at the hardware store and cut the heads off and filed them smooth. That goes in there with a set screw, or a set nut, a lock nut if you will, that holds that together. This is a 1/4 inch. This opening that it fits into is a 1/4 inch, but hexagonal. So what I've got, what I ordered was some hexagonal brass rod that will fit in that space. It won't rattle around quite as much. So what I'm going to do is cut this to length, probably the same length as the aluminum one. Cut this to length and then have it bored out through, or at least down each end, so that I can tap it for screws. And we'll do the same thing here. For this end, it doesn't need to be threaded at all. What I might do is just file the end of the rod down so it's about that size. And I'll show you why that's necessary here in a second. But first I have to turn this over. I'll just set that there for the moment. Okay. This is the timing sprocket right here. It's a gear. And it has, if you can see right here, here are the teeth that the chain runs on. And then right here is a dip. And there's a slot right there that the lift pin sits down in. When the lift pin is in the position, or when the sprocket is in the position it's in right now, the tone arm is depressed all the way. It's down and playing a record in theory. But when it reaches the end of the record, or someone pushes the change record, this lift turns, or this sprocket turns, and this slowly lifts that lift pin back up again, so it's riding on the regular surface of the sprocket. So that's what lifts the tone arm, is or lowers the tone arm, is that dip. It lowers down onto the record, sits there for the duration of the record's playing, and then is lifted back up again by means of this sprocket. So that's how that works. So now we'll take a look at the rest of the underside and talk about what's going on under there. One other thing I wanted to mention about how this all works before we look on the underside, and that is that the platter itself powers what goes on under there, on the underside of this chassis. So the motor is applying power to the capstan, the pinch roller, which is transferring that power to the turntable, the inside of the rim of the turntable in here. And the turntable fits down on the spindle right onto this surface right here, which is slightly tapered. And that is what gets turned when the turntable turns. Is this thing right here, which powers everything that goes on underneath. So one thing you want to be careful of is to not oil this surface. This doesn't get any oil. It does get oiled a drop or two at the very top where the spindle enters, and a couple of drops right down in here where the bearing is. But this surface here has to be dry so that the turntable can transfer power to the rest of the platter can transfer power to the rest of the turntable when the turntable is turning, which is what turntables do in theory. So that fits down there snugly, and then it's that rotation movement that drives everything that goes on underneath. So now let's look underneath. Okay, here's the underside. Let's orient ourselves. Here's the drive motor. Goes through the top of the platform and then rotates the idler wheel, which turns the turntable, the platter. The other parts are over in this corner is the rod. Remember, the one that goes in at an angle, but that's the record changer unit is under there. So the record changer unit is here. So right here is where the spindle attaches from the top side. Comes right through this assembly right here, which is the clutch assembly. And I'll talk about that in a second. This is the clutch release mechanism right here. And here is the sprocket that holds a number of mechanical things, one of which is our pin, our lift pin, which goes right here on the sprocket. It has this big pusher right here that has to do with lifting or moving the tone arm sideways. And the tone arm itself is on this brass plate right here, or brass looking, I should say. Doesn't really look like brass. And when the tone arm pivots this way. So the tone arm right this minute is pointed that way. It's near the center of the record. And I'll show you what happens when the platter turns and what happens to the clutch mechanism. So I need to reach under there and turn the clutch mechanism in the same way the platter moves, which is this way. Now watch here. The clutch will trip itself, so now it's freewheeling. That means the tone arm is down, and this mechanism isn't doing anything until it plays all the way through the record. So the tone arm is out here. It plays toward the center, toward the center, toward the center. Then it gets to the center and trips this, whoops, stuck. And trips that pawl right there. This is, I forget what that's called. Anyway, that's where the eccentric is, that as this moves back and forth, it throws a switch right here, which triggers the solenoid, triggers the solenoid that releases the clutch, and the whole process starts all over again. So as you might be able to see over here on the side, the tone arm swings out to give room for the next record to fall. As this sprocket turns, it pushes the next record out onto the spindle. Oh, this guy needs to be up like that. Out onto the spindle, falls onto the spindle, and the whole process starts again. The tone arm swings back in and gets lowered. Oh, silly thing there. And gets lowered and plays the record again, and this swings back into place to make sure the record just goes round without any of this working. So that's kind of the cycle. New record is, the tone arm is all the way out. A new record is dropped in. The clutch is, tone arm is all the way out. The clutch is engaged. It turns this mechanism for one whole rotation of this, which does several things. This part moves the record out onto the spindle and drops it. This part over here rotates the tone arm back in and lowers it onto the record. Then this disengages, the clutch disengages, the record plays. As it hits the center, this little toothed wheel starts ratcheting. What's getting stuck is my lift pin. The lift pin is held in place by gravity, and gravity is making it want to fall out that way. So it hits the eccentric in the record and starts going back and forth like this. You can see it right there. It opens and closes the switch. It only has to do that once before it triggers the solenoid, and the whole process starts all over again. So it's kind of cool. It's kind of an interesting mix of electronic and mechanical things that happen to make the record play. What else can I say about this? Oh yeah, power. As I said before, the umbilical back to the 9E21 chassis contains the 110 to drive the main motor, and then it contains the 6.3 volts AC from the filament transformer off the main power transformer to drive this solenoid. The solenoid itself is controlled by this switch right here. There are some filtering things going on right here, and some voltage reduction. And just, you know, making sure it all works smoothly. There's a dropping resistor, 100 ohm resistor there from the 6.3 volts to chassis ground, which is right there. This switch is the one that's activated by the speed selector on top, and this is what selects which turntable is going to be fed back out, which turntable out, or which tone arm output is going to be fed back out the umbilical. As we know, the main tone arm, the 78 RPM tone arm, is here. The other one, though, is, you can't see it under here, except there are a couple of wires coming out of the top that go right here over this switch, and that's the only clue from the underside that this has an extra tone arm, and that's the 33 1/3 tone arm. Now, the funny thing to me is they put, when they built this, since the early days of the Cobra-matic, I think, and maybe even before, they always used a shielded, that's jacketed signal wire to go back to the chassis. And when they added the 33 1/3, it's just a pair of twisted. I mean, twisted is good for AC. Reduces the amount of noise it picks up, but just a plain open air twisted pair that goes over here and gets routed according to the position on that switch. So that's kind of it. There's a off, manual, and automatic switch here. The off is obviously off, depowers the whole thing. The automatic is what enables power to get to the solenoid to start this whole process. The on just powers the motor. It doesn't power any of this, so you're free to lift the tone arm and set it down on whatever record you want, as long as it's either 78 or 33 1/3. If you switch it to automatic, the automatic only runs the 78 portion. 33 1/3 doesn't have any automatic functions. You can put it there, I suppose, but nothing will happen over here. Because assuming this is in the 33 1/3 position, this speed selector. So automatic just fundamentally allows power to get to the solenoid, so you can fire off the whole process, crudely described. The rotation is, the chain goes this way, around from this sprocket, around the clutch assembly, around this, the tone arm assembly, back through the chain tightener, and back to that. Again, the synchronization marks are here. These two have to be lined up pretty close. They're pretty close. This pawl, this is the pawl right here, has to be just about touching. Yeah, right there. So that's, when these are lined up, this pawl has to be touching the release, which is here, and this pin, which is slightly stuck, it's supposed to be right there. This pin is supposed to be right in front of that. The pawl is supposed to be, the clutch pawl is supposed to be touching there, and these two things are supposed to be lined up. That's a synchronized turntable. Pardon the mic cord getting in the way. But that's it. I think we're done with this series. This is my revision to part 7. Hated what I did before in part 7. I hope this will turn out better. But we're going to be finished with the turntable for now. I'll put it back in the cabinet for safekeeping, and next we'll pull out the radio chassis and see what we've got going on there. So until next time, thanks for watching. Take care. Be safe. See ya.